Hello, this is Miss Jones doing the first of the mathscasts for A-level. This is the Venn Diagrams mathscast for S1, one of those tricky topics that people always make mistakes on. Okay, so first of all I'm going to talk you through how to draw the Venn diagram given a few probabilities. So they've given them as fractions here. They've given us events A and B, and the probability of A is a half. The probability of B is a third, and the probability of A intersection B is a quarter. Okay, if you've got to draw a Venn diagram with fractions in, then I'd always make the bottoms the same first of all, so give them the common denominator. So instead of writing probability of A is a half, I'm going to write the probability of A is 6 over 12. So we're using the common denominator of 2, 3 and 4. Okay, probability of B then, instead of being a third, is 4/12, and the probability of A union B, instead of being a quarter, I'm going to write that as 3/12 instead. Makes it a piece of cake now. Alright, so when we draw the Venn diagram, we've got two events, that's two circles with an overlapping bit in the middle. Okay, and then don't forget, for a mark, you must draw the box. Okay, it's not enough to just have the two circles and then have a number floating around outside. You've got to have that box. Okay, what do we know? We know the intersection is 3/12. The intersection is the bit in the middle where they cross. So in there, I'm going to write 3/12. Make sure we label our two circles A and B as well. All right. Okay, so the intersection is 3/12. Now altogether, I know the whole circle for A is 6/12. The whole thing is. Now I've got three of them in this bit here. So to make it up to 6/12, this also needs to be 3/12. When I'm going to do the same for B. So I know that the whole circle for B is 4/12. We've already got 3 in there. So altogether, to make it up to 4, this one needs to be 1/12. Alright, now the whole thing needs to equal 1, or 12 over 12. We've got 7/12 in this bit already, haven't we? In this bit here. So the leftover bit, to make it all equal 12/12, 1 is 5 over 12. So that's how you draw the Venn diagram, and that's a 4-mark question just for that bit, and that helps you with all the other parts of the question now. So we're going to look at the next part of that question. Okay, so firstly they're asking us to find the probability of the union, so the probability of A or B. Alright, so A or B is, well, either you can be just in A but not in B, or you can be just in B, not in A, or you can be in the whole thing. Okay, so this is allowed, this is allowed, this is allowed. The only thing that is not allowed is this bit floating around outside. So the probability of the A union B, meaning A or B, is 3/12 plus 3/12 plus a 12th, which is 7/12. Okay. The next bit is the bit that people find hard. The first bit was easy, to be honest. So it's one of those shrunken sample space questions now. So they've said, given that we're not in B, what is the probability that we are in A? All right, so they've already told you this bit at the end is given that we're not in B. Okay, so we are not, if you look at the diagram again, we're not in there. That is gone. Okay, that's totally gone. So the only thing that we are in is the 3/12 or the 5/12. Okay, so remember, you've got 3/12 and 5/12 on the bottom. Okay, so the bottom of your fraction there is 8/12. 8/12 give you what you want, all right, for the bottom of the fraction. And you want the probability that you're in A. All right, well, if you look at the two things I've circled, this one is in A, 3/12. This one is not, so this one's not allowed again. So the top of my fraction is 3/12. So we can ignore the over 12 because they cancel each other out. We're looking at 3/8 there. All right, remember the other way of doing that is using the multiplication rule. But we'll leave it at that bit for now. Okay, so that was 7 marks for that whole question. And you really did need to use your Venn diagram for the whole thing. A couple more things I just wanted to remind you of before we have a go at a question is, first of all, the facts about mutually exclusive events and then independent events. So mutually exclusive means that if you have one, you can't have the other. For example, choosing a boy from the class and choosing a girl from the class. So the Venn diagram looks really specific for this because there is no overlap. You've got the probability of choosing a girl, the probability of choosing a boy, absolutely nothing in the middle. Okay, that means that the probability of the intersection is 0. It's totally empty, and that is the fact for mutually exclusive. That also means that the probability of you choosing a girl or a boy is the probability of G plus the probability of B. Okay, so if they were any two mutually exclusive events, the probability of the union, the probability of the OR, is just the separate probabilities added together. We don't have to take away anything because the intersection is 0. Okay, now the one for independent events. So that means that one does not affect the other. For example, getting a 6 when you roll a dice and getting tails when you flip a coin. Neither of those affects the other if you do both of those things. Okay, so the Venn diagram looks exactly the same, actually. It's trickier to spot an independent event. Okay, it looks exactly the same. Let's call them events A and B. All right, but what do we know about it? Well, one doesn't affect the other. So if they want to know the probability of A, given that B has already happened, well, who cares that B has already happened, because A has got exactly the same chance. All right, they don't affect each other. That's the same the other way round. So the probability of B given that A, don't care about A happening because B has still got the same chance of happening. So that kind of feeds into the multiplication rule because the probability of A and B happening is just the probability of A times the probability of B. So if you have to show that two events are independent, you can either use this one, okay, so you can find this side, and show they're equal, or you can find their intersection, okay, using the Venn diagram, and check whether or not you get the same thing for doing this, all right? So, for example, if the probability of A is 0.2 and the probability of B is 0.4 and the probability of their intersection that you're given is 0.1, my quick test to see if they're independent, well, the probability of A times the probability of B is 0.2 times 0.4, which is 0.08, which does not equal their intersection. Okay, it does not equal 0.1, does it? So they are not independent. Okay. All right, that's kind of everything. That's the main bits. So I've given you a question here for you to try, which is very similar. Again, making the common denominators, and then have a go at the other stats questions from your pack. Good luck.